Found in a vast burial site near Egypt's oldest step pyramid, this simple carving is known as the Saqqara bird. It is believed to hold the key to an incredible enigma. What is surprising about the Saqqara bird is its aerodynamic precision. The shape of the wing and the fuselage seem to have similarities to modern-day aircraft engineering. Could the ancient Egyptians really have possessed the technology of flight over 2,000 years ago?
Man's always seen the birds and he's wanted to fly himself. And I think the Egyptians thought that flying was a godlike property. And maybe this was their transcending to become gods. One of the ways they would do it would be through flight.
Simon Sanderson is an aerodynamics expert who has long been fascinated by the Saqqara bird. He plans to use the latest scientific techniques to unravel whether the ancient Egyptians developed a model for a full-size flying machine. Using cutting-edge technology developed by the University of Liverpool in England, he will conduct the ultimate flying test.
The top of the wing is curved on both the leading and the trailing edge, which is not quite the same as a modern-day wing, but is a shape that will give some type of aerodynamic properties.
Theory after theory has sought to decode the Saqqara bird. Now, state-of-the-art science will seek to crack the mystery once and for all.
The Saqqara bird has provoked this fascinating discussion as to whether the ancient Egyptians did actually know how to fly.
After painstaking 3D analysis, Simon and his team begin to construct a model of the Saqqara bird.
We're actually going to make a model of the Saqqara bird which is 5 times bigger than the original, because the original was very small. The Saqqara bird is definitely the first step on the way to the understanding of aerodynamics.
Here at one of the world's leading aeronautics research institutes in Manchester, England, Simon prepares to subject the model to a series of scientific tests. This groundbreaking analysis will at last unveil the secrets of the Saqqara bird's aerodynamics. Using this high-tech wind tunnel, the team builds up a complete picture of how the ancient wooden carving would have reacted had it ever flown. By introducing smoke into the tunnel, the team can see clearly whether the model has the aerodynamic properties of flight.
We're running the glider at a constant speed, slowly increasing the angle of attack and then measuring the forces which it's producing. That way we can learn about its flight characteristics.
The results are promising. Perhaps a full-size Saqqara bird could have flown.
At 10 degrees we're producing about a couple of newtons of lift.
Oh, 10 degrees, it's 4.5 newtons of lift.
So we're actually producing 4 times the glider's own weight in lift.
Yeah.
So it actually would be flying now.
Yeah.
That's good. We're getting close to going and building a flyable Egyptian glider.
Simon's findings suggest that over 2,000 years ago, the Saqqara bird may have soared high above the Egyptian desert. Simon takes the model to Liverpool University, where it must face the same trials as a modern fighter jet. Using data obtained from the wind tunnel experiments, the ancient Saqqara bird is to undergo the most rigorous scientific analysis that 21st century technology can deliver.
Yep, ready for the test?
Champion glider pilot Simon Sanderson's skills will be pushed to the limit as he tries to negotiate a virtual 3D landscape modeled on the ancient Giza Plateau. At the rear of the carving, a segment has broken away at precisely the point that a tailplane might have been fitted. Back at the wind tunnel, Simon and his engineers make the crucial adjustments to the model. As the pilot takes the controls, the model begins to climb towards the heavens. The Saqqara bird glides effortlessly high above the Egyptian plateau, riding the air streams like an eagle. Over 2,000 years after the ancient Egyptians carved this mysterious bird, modern technology has proved beyond doubt that it could have flown.
It was incredible. And the Egyptians had very sophisticated knowledge in other areas, so why not in aerodynamics as well?